plates. So advantages, disadvantages, and coming to the applications, it's mainly for bulging and flaring of tubes. I have given the example of bulging. Flaring is opening up at the top. Okay. So in a similar way, we can expect that to happen depending on the shape of the die cavity. So bulging and flaring of tubes is the major application of this confined type. Well, with this I complete explosive forming. Again, to take an overview of this lecture, the COVID lecture 1, forging, rolling and HERF processes are in unit 2. Forging has been covered in all divisions. Rolling will be covered by Dr. Nikhil in this week. And HERF processes is what is under discussion now. This is the first lecture. Tomorrow in the next lecture, we will complete the remaining 2 processes. So the first process, explosive forming, we have finished. Okay. So try to go through the book and read and maintain good health and try to keep more positive than usual. Good luck. Have a good day.
ಸ್ಟಾರ್ಟ್ ಅದಲ್ರಿ? ಹಲೋ, Uh, sorry for the interruption. There was problem with some mic, and therefore I had to go and replace the mic. Let us go with this problem as stated. A pair of helical gear is used to transmit 20 kilowatt power. Therefore, the power to be transmitted is 20 kilowatt. At 1440 RPM, therefore RPM of the pinion is 1440 RPM is the RPM of the pinion. To a machine input shaft running at 360 RPM, therefore RPM of the gear is given as 360. From this, if you want, you can find out the velocity ratio. If you want NP by NG, you can calculate 1440 divided by 360. We have approximately 4 times. Therefore, I think it is 4:1. Therefore, there is a speed reduction from 4:1. 4 times the speed is reduced. The motor shaft pinion has 18 teeth. Therefore, the number of teeth on the pinion, it is given as 18. Now, type of the teeth, it is 20 degrees full depth. For the pressure angle, if you take, it is 20 degrees full depth teeth. Then helix angle, yes, they are helical gears. For helix angle is given as how much? 30 degrees is the helix angle. Both the gears are made up of the same material, that is cast steel. Therefore, gear and pinion made up of cast steel. Both are made of cast steel having static strength of 100 megapascal. Good. Therefore, given is this is equal to pinion, that is equal to 100 megapascal. Both the gear and the pinion are made up of the same material. Design the gears for 20% overload. Yes, overload has been given to you. Therefore, we have to design for overload. Overload of how much? 20%. Therefore, this is the statement of the problem. Okay. Now, to proceed with the design, yes, we need to, as you know, the steps involved are: first, check for which is the weaker member. That is using sigma into y. Calculate sigma into y for the gear, sigma into y for the pinion, where sigma is the strength and y is the levy is the form factor. You can make use of those equations related to 14.5 degrees or 20 degrees or 20 degrees step tooth. Find out both the values and check which is the weakest, and we need to proceed with the weakest part. However, if you see when the materials are same, if we have what I am comparing is sigma into y. For sigma, that is sigma of gear into sigma and y of the gear, sigma of pinion and y of the pinion, Now, when both the materials are same, it is only depending upon the form factor yg and yp. Therefore, if you see yg and yp, already you know in spur gears also I have seen, when both the materials are same, naturally the pinion will be the weaker member compared to that of the gear. Therefore, we have to design for the pinion. Therefore, when both the materials are same, or if you know y is nothing but given as a minus b by z. This is the equation, a minus b by z. Now, higher the value of z, lower will be this value, and therefore y is going to be on the higher side. Therefore, here the pinion is the weakest of the two. Therefore, we can directly go ahead with the pinion. Therefore, we can first write check for the weaker. Check for the weaker member. Weaker member. Okay. As you can write the statement as both gear and pinion are made of same material, pinion is weaker member, and design is based on pinion. And design the pinion. Therefore, this is the first part. Okay. Second is we need to now find out the velocity and thereby the tangential loads. Therefore, first we will calculate, anyway we have to go with pinion for power transmitting capacity with 200. Okay. Total power to be transmitted. Total power to be transmitted considering overload. Considering overload will be equal to. So only 20 kilowatt has to be transmitted and 1.2% overload. So 20% overload, there you have to transmit a power of how much? Around 24 kilowatt is the power to be transmitted. Therefore, we have to design the gear not for 20 kilowatt, we have to design the gear for 24 kilowatt. Therefore, this is the first one. Now, the tangential load, how will you calculate the tangential load? We know power is equal to tangential load into velocity. Now, here pinion is weaker, therefore, velocity of the pinion. The velocity of pinion is 5 times diameter of the pinion into RPM of pinion divided by 60. A simple equation. We don't know the diameter, therefore, divided by 60. Now, if you are taking module in meters, yes, you do not have to divide it by 1000, but if you are taking module in millimeters, if you take in meters, it will be decimals. Therefore, take module in millimeters, therefore, divide it by 1000 to get the velocity in meters per second. Therefore, this will get the velocity in meters per second. Therefore, we know the value of m. Zp is given as 18. Yes. Now, one more thing. Don't take the virtual number of teeth here. No. Virtual number of teeth is only taken for the Levy's form factor. Here we have to take the number of teeth in the diametral plane, because RPM we are measuring in the diametral plane. Therefore, number of teeth in the diametral plane is 18 into RPM of the pinion is 1440 RPM. 1440 RPM divided by 60,000. Therefore, it deals with 1.36 module meters per second. Therefore, the velocity is 1.36 times the module. Therefore, we got the velocity. Once you get the velocity, now we have to get the tangential load. Therefore, the tangential load is obtained by simple basic equation. Therefore, tangential load is power divided by velocity of the pinion. Power is 24 kilowatt, that is 24 into the power of 3 watts, divided by 1.36 times the module. This is nothing but the tangential load acting on the gear tooth. And already have calculated the value. It comes to be around 17647 divided by m Newton. Therefore, also the tangential load will be in terms of the module. Velocity is also in terms of the module, which is unknown. We need to be determined. Okay, once we calculate the tangential load. Okay, now we need to proceed with the form factor and all. Therefore, let us calculate the virtual number of teeth. Next is virtual number of teeth, or the formative number of teeth, or effective number of teeth. Virtual number of teeth, only let us calculate, because pinion is the weaker when both the materials are of same. Therefore, it will be Z of pinion divided by cos cube of psi. That is equal to Z of pinion is 18 divided by cos cube of, what is the helix angle? 30 degrees. Therefore, if you take 18 divided by cos cube of 30 degrees, it turns out to be about 27.71. Okay. Then calculate. Okay. Now we have to find out that y. Levy's form factor. Y for the pinion. Now refer to your data handbooks. For the form factor, the 20 degrees full depth. It is given on page number 218, equation number 16.11b. So what is that? It is given as 0.154. So the equation is 0.154 minus 0.912 divided by it will be ZVP. That is 16.11b. 11b. This is the equation what we are making use of to get the virtual number based on the virtual number of teeth. Therefore, if you use that, the answer what you are going to get, if you substitute the value of ZVP. Here if you substitute the value of 27.71, you are going to get it as 0.121. Therefore 0.121. Therefore this is the value of YP. Okay. The next, let's now go ahead with the equation for the tangential load and see what all things we know and what to be estimated still. Therefore tangential load is nothing given by the velocity factor into the static strength into B into M into capital Y into cos of psi. This is the equation, out of which this is to be found out, unknown. kV, we don't know the velocity, therefore we can't find out the value of kV. Sigma of P, yes, given as 100 megapascal there. Phase width, yes, phase width is not given. In the previous problem, phase width was given in terms of the module. Now phase width is not given, therefore we can assume the value of phase width, equation number 16.26. Therefore it is given as 1.15 pi times m divided by tan of phi 2. It is given as 2 times px, where px, if you see, this is equation number 16.26. 16.26, where value of px is the axial pitch, that is pc by tan phi. Therefore this comes to be 1.15 pi divided by tan of phi 2. 2 times it is pc divided by tan of phi. Okay. This is given as equation 16.23 for this value px. This value is c divided by tan of phi. We already know that pc. What is pc? It is a circular pitch, and pc is equal to pi times m. Therefore the equation becomes 1.15 pi m to tan phi to 2 pi m tan phi. Therefore you are free to choose the range. Now if you substitute the values here, substitute the value of tan phi, what you are going to get here is, it will be about 6.26 times module 2, it will be about 10.88 module. Therefore within this range you are free to choose, assume the value of phase width. That based on this phase width we will be designing the gear. Now as we are free to assume any value in between 2, let us assume that B be about 10 times the module. This I am assuming, okay. Therefore measure, mark whatever you are assuming clearly. Therefore we are going with phase width is 10 times module. Therefore out of this equation, this is over, this is over, this is unknown, module is to be calculated. Y, this y is nothing but, as you know, it is pi times y of the pinion. Y of pinion already have calculated as 0.125, therefore that is also known. So values in this. Okay. If you substitute, what are you going to get? Therefore tangential load, yes, we know tangential load as 17647 divided by m is the tangential load, yes, as it is. The value of what is that, kV, we don't know, therefore let us keep kV as it is. We don't know the value of kV. Sigma p, yes, it is 100 megapascals, yes, we know. Phase width is, they are taken as, assumed as 10 times module, therefore it is 10 times module. Then module into m, we don't know value of m. Y is pi times y, therefore it is pi times 0.121, correct, into cos of 30. Into cos of 30, yes. If you see this values, we have substituted all those values. This is the value of Wt, what we have calculated, considering overload. kV, we don't know velocity factor. 100 is the strength, 10 times module is the phase width. This is the form factor, this is the excitant. So there are two ways of solving the given problem. One thing is you can assume the value of kV. The values of kV have been stated for the helical gear. If you refer to all those equations right from 16.3 to 16.36, you can assume 16.36 is for non-metallic gears. After 16.35, you can assume the value of kV and go ahead with it, and then check for the strength of the gear for what you have designed. On the second is, I'll keep kV as unknown and I'll go with the second method. In that case, if you see, you can rearrange the equation. This is m kV m. I can write as m cube kV. Therefore, I have two parts, m cube kV. M cube kV, if you find out, if you actually solve it, this comes to be 53.6. M cube into 17,17647 divided by all these values if you take. If you simplify, this gives M cube kV into 53.6. Now, we'll assume different values of M. Once you know value of M, we know the velocity of the pinion in terms of the module. Okay, we know the velocity. We can calculate the estimate the value of kV and then we can check. Therefore, I'll just make a tabulation here. Anyway, you are free to choose any one method. I am assuming the value of the module. Once we know the value of module, we can calculate the velocity of the pinion. Velocity of the pinion, already we have known in terms of module. Velocity of the pinion is 1.36 times m. If 1.36 m is the velocity of the pinion. Once we get the value of velocity of the pinion, can calculate the value of kV, the bar factor. Then once we get the value of kV, now let us calculate m cube kV. M cube kV. Now I have done for references so that I will not waste. Therefore, if you take m is equal to 4, assume m is equal to 4. If you assume m is equal to 4, I will substitute m here. It will be 1.36 into 4. Therefore, that comes to about 5.44 meters per second is the velocity. 5.44 meters per second is the velocity. Now I will refer to the data handbook for the bar, the factor, velocity factor. 5.44. Therefore, the first one 16.32 is less than 5. Therefore, more than between 5 to 10 meters per second, it is equation 16.33. Therefore, kV will be 6 divided by 6 plus V. The V I will be taking it as 5.44 and that turns out to be how much? It comes to about 0.524. Therefore, this value will be 0.524. Okay, 0.524. Now, m cube kV, if you take m cube 4 cube into this comes to about 33.53. But we need about 53.6. This is the value what we need. Okay. Then next is I'll go with 5. If you take 5, 1.36 into 5, the velocity will be 6.8 meters per second. And corresponding to 6.8 meters per second, again it is less than 10 meters, 5 to 10, it will be 6 divided by 6 plus V, correct? 6 divided by 6 plus V, it comes to about 0.469, 0.469, okay? Then again if you take m cube kV, it comes to about 58.62, 58.62. And now if you compare 53.6 and 58.62, yes, it satisfies. Therefore, let us assume the value of m equal to 5. However, you are free to assume the value of kV, substitute the value of kV, you know value of kV, m cube you get it, then again resubstitute and check for the strength. Or by using this method, any one method you can do it. So once we know the value of module, the module is 5, it is satisfying our conditions, equation. Therefore, now based on that, let us specify the dimensions of the gear. Therefore, the module, we get it as 5 millimeters. Therefore, here we are assuming the modules. This is assume module M. Once you know value of module, diameter is module times Z of P, M into 18. That is how much? 5 into 18, right? 5 into 18 is 90 millimeters. Is the diameter of this. So the diameter of the gear is module into Z of the gear. Now Z of the gear, yes, we have to calculate the number of teeth of the gear or directly by using velocity ratio. It is 4 times. Therefore, it is 4 times. Either directly multiply 90 into 4, it will be 360, or calculate the Z of ZG. How will you calculate? ZG by ZP is NP by NG, and that is equal to 4 by 1. Therefore, ZG is 4 times ZP, correct? Right. Now, what is 4? What is the number of teeth on the pinion? Number of the teeth on the pinion are 18. Therefore, 18. Therefore, how much it will be? 72 teeth. Correct? Yes, it is 72 teeth. Therefore, it will be 5 into 72. This will be how much? 360 millimeters. And similarly, the face width, it is 10 times the module. Module is 5. 10 into 5 is 50 millimeters. Therefore, these are the dimensions of the gear based on the static strength what has been asked in the numerical. Clear with it? Hope it is clear. Just practice it and see if you have any difficulty. If you have difficulty, you can just revert back and inform. And just to wind up, here today we have just gone through in brief very quickly what are the equations to be used for design of helical gears. The first problem is solved based on the design of helical gear, that is power requirement, power transmitting capacity. In that case, all the dimensions of the gears are known to us. In some, we need to assume and determine the value of tangential load. Once you know the tangential load, main thing is to calculate tangential load. If you know tangential load, you know the velocity. W into velocity gives the power transmitting capacity of the gear. That is the first problem what we dealt with. The second problem dealt with the design of the helical gear, where we have to determine the dimensions of the gear, not just like the previous case where dimensions were given. Now we have to find out dimensions. Power transmitting is given. Material for both the gears were same, therefore when materials are same, check for which is the weaker part, then get its velocity, use the Levy's equation, and using the Levy's equation you can find out the module and thereby calculate the dimensions. Therefore, whatever we have dealt today in the class is just based on the static strength, but however for the complete design of the gear we have to check the gear for dynamic load as well. Only if it satisfies dynamic gear load, then the dimensions are satisfactory. In the next class, we'll take up one simple numerical based on the complete design of the gear, that is static. Using static, we'll get the dimensions and check the dimensions for the dynamic load. Okay? Thank you. Thank you.